Hi everyone, in this lecture we are going to understand about the electric circuit. So let's start now. What is the electric circuit? Electric circuit is just a path through which electrons can flow. Whereas your electric circuit always be a closed path. That's why on the behalf of that we can also define it like an electric circuit is just a closed loop along which electrons can flow. A circuit consists of many components and all of those components can be represented by a symbol, just like if the circuit is on, then it can be represented by a closed switch. If your circuit is off, it is represented by the open switch. This one is the resistance which always try to oppose the electric current flow. This is the electric bulb, and electric bulb is a device which consumes the electrical energy. That's why we can also say it is a load. This one is the voltmeter, and voltmeter is just a measuring device which used to measure the potential drop across the electrical components. This is the ammeter. Ammeter is used to measure the electric current flowing through the circuit. And now the next one is the open and closed circuit. What is the open circuit? Open circuit is just only and only means your switch is off. Your switch is off. If the switch is off, then the loop of the circuit will not be completed. In that case, your electrons will not be flow through the circuit. Hence, the appliances connected within the circuit will not work. The next type of circuit is the closed circuit. In the closed circuit, the closed switch means your switch is on. Your switch is on, and if the switch is on, then your circuit is closed, and you can say your electron can flow within the circuit and the appliances connected within this circuit will work. And now a little bit we are going to understand about the components of the electric circuit. A circuit requires at least three basic parts. The first one is the energy source. Something which provides the energy to the circuit is said to be the energy source, just like electric battery. The second one is the electric generator. Electric generator. The second one is the switch. Switch is used to control the electric current flow within the circuit. The third one is the load. All of the devices which consumes the electrical energy within the circuit is said to be the loads, just like the electric bulb, fan, electric heater, refrigerator, electric iron, and so on. Load also converts the electrical energy into another forms of energy, just like the electric bulb. Electric bulb converts electrical energy into the light energy. Similarly, the electric motor also behaves just like a load, and electric motor converts electrical energy into the mechanical energy. Hence we can say that load also converts electrical energy into another forms of energy. Now the types of circuit. In this there are two types of circuits are found. The first one is the series circuit and the second one is the parallel circuit. First of all, we are going to understand about the series circuit. In the series circuit, there is only one path through which electrons can flow. Hence, we can say if this is a circuit having the voltage of V and the current passes through the circuit is I, then you can say the electric current passes through each and every element will be same. It is because the circuit have only and only single path to flow the current. The second one is the voltage. Voltage depends on the resistances of the individual elements connected within the circuit. That's why the voltage across each element will be different. Just like this is your resistance of R1 and the voltage across this is your V1. This is your resistance of R2 and the voltage across this is V2. This is your R3 and the resistance across this will be V3. You can say the total voltage will be V is equal to the V1 plus V2 plus V3. You have already know V is equal to IR. So from here we can extend this equation. IR is equal to IR1. For the resistance of R2 it will be IR2. For the resistance I3 it will be IR3. If we take the common electric current from right hand side, then we will get I in bracket R1 plus R2 plus R3. Here this is your I into R. I is cancelled with the I. It will be R is equal to R1 plus R2 plus R3. This is the equation of the resistances connected in the series. And now we are going to attend basic questions related to the series circuit, and that is, suppose the resistances of this circuit is of 2 ohm. This is your R1, this one is your R2, this one is your R3, and resistance of R1 is 2 ohm, resistance of R2 is 3 ohm, and the resistance of R3 is 3 ohm also. Then what will be the total resistance? The total resistance of this will be equal to the R1 plus R2 plus R3. After putting the values of R1, R2 and R3, we will get 8 ohm. This is the equivalent resistance of the given circuit. Now, the next one is the advantages and disadvantages of the series circuit. Suppose that if the number of appliances are connected in the series circuit, then in the case if any one device is fail or burn out, in that case your circuit will break and your device will not work. So this is the disadvantage of the series circuit. Similarly, the series circuit have advantages also. The series circuit is useful in some many ways also, just like in burglar alarm. If any one part of the circuit in a burglar alarm fails, then due to lack of electric current signal, a problem exists and the alarm will sound. Now, let's move on one another question. Use the series circuit pictured to the right to answer A to E. The first one is the total voltage across the bulb. You can look at here, your battery is of 6 volt and this 6 volt battery provides the energy to whole of this circuit. Hence, we can say the voltage across all of the bulb is 6 volt. The second one is the total resistance of the circuit, and now from the circuit it is clear that all of the resistances are connected in the series. That's why the series combination equation is R is equal to the R1 plus R2 plus R3. After putting all of these values, you will get 1 plus 1 plus 1. It will be 3 ohm. This is the total resistance of the given circuit. The third one is the current in the circuit. To calculate the current in the circuit, you require the voltage of the circuit as well as the total resistance of the circuit. Here we have already calculated the total resistance of the circuit is 3 ohm. That's why we can use I is equal to V over R. The voltage across the given circuit is 6 volt over 3. It will be 2 ampere. Part D is voltage across each light bulb. Now we can calculate the voltage across each light bulb because we have already know in the series circuit the voltage across each and every element is different. Suppose that this is your bulb 1, this is your bulb 2, this one is your bulb 3, and the potential across the bulb 1 is V1, potential across bulb 2 is V2, and the potential across bulb 3 is V3. And now we can calculate here V1 is equal to the IR1. What is the amount of current flowing through the circuit? The current flowing through the circuit is 2 ampere. We have already calculated here. Into R1 is 1. We get 2 volt. Similarly, the voltage across the bulb B2, it will be V2 is equal to IR2, which is equal to the 2 into resistance is again 1 ohm. It will be total 2 volt. Similarly, after calculation of the V3, once again you will get 2 volt. And now the last one is that draw the path of the current on the diagram. You must remember that the electric current always start to flow from the positive terminal of the battery. This one is the positive terminal of the battery, you can see here. So that's why electric current will start to flow from this end of the battery, and it will flow like this. And now the another type of circuit is parallel circuit. In parallel circuit, the charges have more than one path to flow, or you can also say all of the devices in the parallel circuit is connected between the two ends. This one is your end A and this one is your end B. You can see in the diagram your bulb B1 and B2 are connected from the same end. And in the parallel circuit, the electric current through each device will be different because there are more than one path exist within the circuit. Suppose the electric current coming from the positive terminal of the battery is I till the point A, and at the point A your electric current will divide into two parts. The first one you can consider here, it is I1, and this one you can say here I2. Whereas the voltage across each of the device will be same, because we have already know each and every devices are connected parallel with each other with the same points. That's why your voltage always be same in the parallel circuit. Next one is the advantages of the parallel circuit. The advantage of the parallel circuit is that each and every branch of the circuit work by itself independently, means you can use your electric bulb or your fan or your electric heater or the refrigerator individually. Hence, you can use any one of the appliances at a time. And now let's try to solve an example related to the parallel circuit. Use the series circuit pictured to the right to the answer questions A to C. The first part is total voltage across each resistor. As you have already know, in parallel circuit, voltage across each device is same. Hence, we can say the voltage across each resistor will be 9 volt. As you can see here, the 9 volt battery is connected within this circuit. The second part is current in each branch. The current flowing through this branch we can consider is I, but after reaching at this point, it will divide into I1, I2 and I3. So I1 will be equal to V over R1, and now V is the 9, R is 2. After calculating you will get 4.5 ampere. Similarly, current I2 can be calculated. This is your I2 will be equal to V over R2, which is equal to the 9 over 3, and this is your 3 ampere, and I3 will be V over R3, which is equal to the 9 over 1, that is the 9 ampere. Last one is the total current provided by the battery. Hence, we can say the total current will be I is equal to I1 plus I2 plus I3, which is equal to the 4.5 you have calculated here, and 3 plus 9, which will be equal to the 16.5 ampere. And now the last one is the circuit safety devices. There are two circuit safety devices are given. The first one is the electric fuse. What is the electric fuse? A fuse has a strip of metal. As you can look at here, there is a strip of metal is connected at both ends of this. Okay, and now the melting point of this material is very low. So when the charges in the circuit flow through this strip, if the current is too high, the metal strip melts. That why you can say your circuit becomes open. Hence, as a result, the circuit is broken, the charges stop to flow. The second one is the circuit breaker. It is a switch automatically open if the current is too high. In this, magnet or bimetallic strip is used to open the circuit. What is a bimetallic strip? Bimetallic strip is just like a strip which is made by the two different materials. Okay, due to this of two different materials, the melting point of the both of the materials will be differ. When the metal of the strip warms up, it bends and opens the circuit. Circuit can be closed by just flipping a switch after the problem has been fixed. This is your circuit breaker. This is your circuit breaker, you can see here. Nowadays, circuit breaker is mostly preferred by the companies because it do not need to replace each time when the circuit is open. Because if you are using the electric fuse, then after damaging this, you should remove this and you will connect the another new electric fuse. Then your circuit will be closed. So now electric circuit is finished. I hope all of you are completely understand this topic in one of the easiest way. Okay, thank you. Bye bye.